All right, we're getting into part 2 of, oh my gosh, I lied. We are in lesson 17, which is false positives, false negatives. And it's really, the concept of this is a little bit more difficult to wrap your head around, but once you get it, it's really, I think it's really interesting. So this is a really blurry picture of the first page, and what we're talking about, right, is the concept of false positive, false negative. And I guess I want to start on my page 2. And what does it mean if you are given a false positive or a false negative? So I think the easiest way to think about this is in terms of like medical tests. So you go to have your test done, maybe HIV testing, which is this first example. If you are given a false positive, okay, first, what does the word false mean? It's not true. So you are given a not true positive result. Right? So they say, I'm sorry, Betty, but you have HIV. Well, a false positive means you've been told that, yes, you have it. Been told, yes. However, you don't have it. Oh, I forgot the word have. You don't have it, right? It's a not true positive result, and it happens. Now, similarly, we have what's called a false negative. So you go in, right? Let's say it's a cancer test, and you know, they do a scraping, whatever, and they're looking in your lymph nodes for whatever reason, and they say, oh, you're good. You are clear. The results are negative. You do not have cancer. But it's false, right? So basically, they lied to you. They said, hey, you're good. You don't have it. But you really do. So, so for a false negative, you actually have it, whatever it is. So when you go back to page 153 in your packet, it would be very beneficial for you to read through this. Okay? So when we're talking about the accuracy rate for HIV testing is 99%. So 99% of the time the test is accurate. So if you have HIV, 99% of the time your result will be yes, you have it. And if you do not have HIV, then 99% of the time your test will say, no, you don't have it, because it goes with it. However, there is some inaccuracy. So 1% of the time the test is inaccurate. And we are going to take these numbers and put them into a table. All right, so this table at the bottom, page 153, if you have HIV, you would expect to test positive, right? You actually have it. So that's where 99% comes into play. You have it, and you expect to have it. Now, I'm going to go with the 99%. I'm going to keep that going. If you do not have HIV, you don't have it, you would expect to test negative. So 99% accuracy means if you don't have it, you're going to test negative. And that should make sense, right? Use logic for these. Okay? Now, the other side of that, if you have HIV, there is a chance that you will test negative, right? And that's 1% of the people. Because if 99% test positive, 1% will test negative. Similarly, in the not have HIV, every once in a while a mistake occurs and 1% test positive. Now, in these two blue categories is where we have our falsies, right? Now, in this column here, it's negative. This is what we would call the false negative, because they told you, no, you don't have it, but you really do. So that's a false negative. And here in the other one, this would be the false positive. They told you that you have HIV, but you really don't. All right? So hopefully that makes a little bit of sense, at least here in the beginning. All right. It'd be great if you could answer these questions on your own, but because this is a new concept, I don't really expect it. So let's kind of go through these together. In the top here, we say, in reality, a very small percentage of the population has HIV. In America, only about 0.5% has HIV. So what percent does not have HIV? So remember, we would take the 1 minus. Well, we're dealing with percents, so let's go ahead and say we have 100% minus 0.5%. So that gives me an answer of 99.5% of the population does not have HIV. All right, let's go on to the questions. All right, number 3. If 0.5% of the population has HIV, how many people out of 100,000 would be expected to have it? Now, here's the key. It says of the population. That word of means multiply. So 0.5% as a decimal is 0.005, and we're going to multiply that by how many people we have, and that's 100,000. So if I take 0.5%, which is 0.005, multiply it by 100,000, we would expect 500 people out of that 100,000 to have HIV. All right, so that's just common numbers. Now, number 4, we get into the accuracy rate. How many of those with HIV will test positive? So these people have it, right? They actually have HIV. So when I look at number 4, we know that there's a 99% accuracy rate. So 99% of those that have it, which is 500, will test positive, right? A positive result, positive, and that is 495. So 495 out of the 500, when tested, will test positive for HIV. And that should make sense because they actually have HIV, right? Now in number 5, how many of those of HIV will test negative? Well, you can do this 2 ways. One way, we know 500 people have HIV and 495 tested positive. So that means 5 of them will test negative. The other way, so that's way number 1. Way number 2 would be to say, well, inaccuracy rate is 1%, which is 0.01, excuse me. If you take that and multiply by 500, you also get an answer of 5. So you can either use that whole concept of complements, or you can use the concept of inaccuracy rate. Okay, let's go to number 6. How many people out of 100,000 would not be expected to have HIV? Well, we know that 99.5% of people do not have it. So as a decimal, that's 0.995. Let's multiply by 100,000, and that will give me my 99,500 people who don't have it. Now again, you could have taken the 100,000 and subtracted the 500 who have it, right? Either way works fine. So, how many of those without HIV will test positive? So remember, these people do not have it. They don't. They are HIV free. But we know there is an inaccuracy rate of 1%. So 1% of those 99,500 will test positive. So 995 people will walk out of the doctor's office going, oh my gosh, I have HIV. When really, in fact, they don't. Right? So that's what we would call a false positive. Now, number 8, we're dealing with a complement. How many without HIV will test negative? Well, remember, we've got 99,500 total without HIV. 995 tested positive in number 7, and so the rest, 98,505, will test negative. All right, we are now going to take this information and put it into the table at the bottom of this page. All right, so we have a table, and we're going to spend some time, especially in class, working on how to set these up. So when you think about it, right, we first started with how many people have HIV, right? That was question number 3. How many people out of 100,000, right? So there's my total 100,000. How many would be expected to have HIV? And we know that that answer is 500. And therefore, if that's 500, those that don't have it are 99,500, because those totals added together gives me 100,000. Now, when you think about the accuracy rate, we know that 99% will if you have it, you will test positive 99% of the time, right? So there's your 99% times 500. That's where our 495 goes. Similarly, 99% of the 99,500, if you don't have HIV, you expect to test negative, which would give me 98,505. Now, we've already found these other numbers, so we know that if you have HIV, you test 5 people will test negative, and we know that if you don't have it, 995 people will test positive. So you should also add these numbers up, and when you total the test is positive, we come up with an answer of 1,490, and these would be 98,510. Once again, double check. Add together your test is positive, test is negative totals, and make sure that together they're 100,000, because if they're not, you've got a boo-boo. Okay, so in questions number 9, how many positive test results are there in total out of 100,000? Well, you can see that clearly right here, 1,490. How many negative test results are there in total? 98,510. How many false positives? Okay, so false positives, that means they tell you you have it, but you don't. Okay, so here's the people who don't. This is where they tell you that you do. So right here is the false positive. So there are 995 false positives. False negatives, they say you're free to go, you're nothing to worry about it, but you really do. And this is the same as a probability table, right, which we've created before. Now, one thing we will definitely talk about in class is, what do you think is worse, a false positive or a false negative? Right, so a false positive, they say, hey, you have it, we need to start treatment, blah, 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 blah. And if you don't have it, they send you on your way and you live your life as you see fit. So what do you think is worse? And this is a very heated conversation, and it can go either way. Some people think that the mental anguish you go through being told that you have a serious thing like maybe HIV or cancer could do more harm than living with the disease and letting it go untreated. I think that is up for a personal, whatever. I would rather know if I have it. So I think the false negative in my world would be worse, because I don't want to live with something, being tested for it and then being told I didn't have it when really I did. I think that that sounds worse to me. So that's just my personal opinion. All right, let's go ahead and move on to page 155. Okay, at the top of page 155, we see questions 13 through 18 that deal with probability using the table we just created. So I want you to hit pause, knowing what you know about probability tables, use the table we just created to answer these questions, and then come back. All right, looking through these. Probability of having HIV if given a positive test result. Well, a positive test result means your denominator is 1490 and positive is 495. So that would give us a decimal of 0.332. And 14, not having HIV if given a positive test result. Well, you could use your complement, or you could simply say that would be 995 over 1490. Either way. 15, probability of having HIV if given a negative test result. So a negative test result, there are 98,510 of those. 5 people have HIV out of that. So I've got to take my decimal out a little farther just to get a number. And 16, again, would be the complement of that. So you could do it that way to get your 0.99995. Or you could do the 98,505 over 98,510. So if you are told that you don't have it, it's very, very likely that is true. The probability of a false positive, or excuse me, a false negative is very, very unlikely. 17 and 18 are very much opinion. I think false negative, I explained that on a previous page, and I think you can have all kinds of opinions in number 18 too, and we're not going to get into that here in this video. So this here is video number 1 of false positive, false negative.